Pascal found out that the pressure is a change in the pressure applied to enclosed fluid is transmitted undiminished to every point of the fluid and to the wall of the container. So we've written that down. That is a very simple rule. I don't know who gave him that idea, but that has to be proved to be true. It says a change in the pressure applied to enclosed fluid including gasoline, oil, and water is transmitted they use the name called undiminished to every point of the fluid. Points of the fluid and to the wall of the container. So it's transmitting everywhere, equally. Okay. Now that's the key. Now, so how would the people apply it? So they draw this. Here is the music container here. So when they are under the control leveling, there's no outside adding, so that is in a level. So that we have something applied to it. The force are being changed. So we apply the force to the area. So when we apply to here is F1. And the area is A1. And then this force come out is F2. And this is the area is A2. So when you push this down, and then the pressure is transmitted. So, and then come to here. So this pressure, by the say, is P1. So that is equal to F1 divided by A1. And this pressure from this end is P2, in which cases is equal to F2 divided by A2. Equal to F2 divided by A2. The key thing is, he says, transmitted undiminished. Using the layman's word is unchanged. Unchanged. So like this and that. So if a P1 and P2 is unchanged, then it's equal. So now we do one more step. Then we have F2 divided by A2 is equal to F1 divided by A1. So we have F2 divided by F1 equal to A2 divided by A1. Ladies and gentlemen, so what is this? What is that? So in these cases, the area is a force multiplier. That means F2 is equal to A2 divided by A1 times F1. So that is the situation here. Okay? So, ladies and gentlemen, here is the case. So, quite a bit. First, in your brake system, you press the brake, then it transmitting the pressure to the drum of the tire. The drum is big, and the pipeline, when you push the brake, is built a tiny line like this, and it transmitting the force. So that's why a young lady here is only weigh until weigh almost like 100 pounds. They can basically push the brake and stop the 3,000 pound automobile. Okay, you try it. All right. I think one lady only 90 pounds. You can stop the car very easy. Just push the brake, right? And then if you're using the garage lift, again, is they have lift the automobile about more than 5,000 pounds. And auto mechanic push it, the button is very easy. Just ka-chunk, the things will start doing. So this is what we're talking about. The Pascal's principle is a very useful and dynamic one. So we'd like you to apply it to our job. Using engineer in automobile have to know about this, very important. That means we already tell you something is important. If you want to be a shipbuilder, you got to know Archimedes' principle, and then you start studying Archimedes the principle in detail. And then if you are going to be in auto mechanics, you have to study the Pascal principle very well, and so that will help you in your career. Now, the next thing we are going to talk about is section 15.6, and then the next one is they call the 15.7. This one is called Bernoulli's principle. Bernoulli's principle, and O-U-L-L-S. They call either principle or they call equation. Principle or equation. Okay, so now first we like to say something is flowing under the water. What is the situation? So so we like to say, first we like to study what we call continuity equation. Continuity equation. What we're talking about is the water flow under the water. Under the water. So the water is flowing from here to here. So this is called pond 1, and then pond 2. So ladies and gentlemen, look at this. When you're talking about physics, you basically have a lot of diagrams, a lot of pictures, a lot of conceptual diagrams. Can you imagine that if you solve a physics super genius, or you then memorize the solution, or copy out from the solution menu. Something is very bad for solution menu. There's no diagrams there. So okay, so we want to do the thing. So when you flow during certain time is delta x1. And then they have an area, A1 in here. A1 is in here. So they have a velocity is transmitting is V1. And this one has the same thing, have an area 2 And then I have a delta x2. And then have a A2, have a V2. When this is flowing, then we know that if this part of volume travel to that part of higher volume, then A1 times delta x1 equal to A2 times delta x2. That means the volume, conservation of volume. This equation is conservation of volume. That means the same amount of volume travel from this point 1 to point 2, and you have that equation. Then we are assuming the velocity is transmitting, so that we divide by A1 delta x1 divide by delta t equal to A2 delta x2 divide by delta t. So what we have is A1 V1 equal to A2 V2. Now this is a free-fall step, and then getting something is very important. What we try to say, area again. Area play a very important role in physics. This one, area become again somewhat like a multiplier, velocity, speed multiplier. So let's look at this using the example